Welcome to this explainer. Okay, let's dive right into this. Today, we're looking at what is honestly one of the most incredible survival stories in human history. It's the story of an aging hero, a robotic pioneer that's been traveling through the dark, freezing void of space since 1977. I'm talking, of course, about Voyager 1. This incredible machine is humanity's very first interstellar explorer, and right now, well, it's facing a critical, nail-biting battle for its life.
So how exactly do you save a spacecraft that is literally 15 billion miles away? That's the monumental, almost incomprehensible task that engineers at NASA's Jet Propulsion Laboratory are wrestling with as we speak. I mean, there's no tow truck, right? There's no mechanic we can just send up in a rocket. The stakes are incredibly high, the environment is unimaginably cold, and the immense distance means that every single decision has to be perfectly calculated before a command is ever sent out.
To really wrap our heads around what's happening, we need to look at how this current crisis kicked off. On February 27, 2026, Voyager 1 was executing what was supposed to be just a planned, routine roll maneuver. But right in the middle of it, the spacecraft's power levels unexpectedly and terrifyingly plummeted. Mission engineers immediately knew they had a massive problem. If the power dropped any further, it could trigger the probe's undervoltage fault protection system. Now, that system would automatically shut down components to protect the craft, which sounds great in theory, but in reality, recovering from that automatic shutdown is a highly risky, drawn-out process from Earth.
You've got to remember, Voyager 1 is way too far out for solar panels. Instead, it relies on radioisotope thermoelectric generators. But after nearly half a century in deep space, it's losing about 4 watts of power every single year. So those power margins have grown razor thin. The team is constantly having to conserve energy by turning off heaters and instruments, walking this incredibly delicate tightrope just to make sure the spacecraft doesn't get so cold that its fuel lines freeze solid.
And this really brilliantly illustrates the sheer scale of the crisis. 15 billion. That is the distance in miles, or 25 billion kilometers, that Voyager 1 is from Earth right now. When that sudden power drop happened back in February, the Voyager team knew they had to act immediately to prevent that automated shutdown. But immediately is a very relative term when your patient is 15 billion miles out in the cosmos.
Let's map out the timeline of this crisis to see how it unfolded. Voyager 1 launched all the way back in 1977. Fast forward nearly 49 years to February 27, 2026, and bam, we hit that unexpected power drop during the roll maneuver. Engineers knew they just couldn't risk the spacecraft's autonomous system taking over and shutting things down unpredictably. So to get ahead of the fault protection system, they had to make a really heartbreaking choice. Which leads us to April 17, 2026, the day the official shutdown command was carefully transmitted from Southern California.
This brings us to the agonizing solution. The team had to execute a painful sacrifice. To keep the rest of Voyager 1 alive and prevent a total system freeze, they had to shut down one of its beloved science instruments. Now, to be fair, this wasn't just a snap decision made in the heat of the moment. Years ago, the Voyager science and engineering teams actually sat down together and deliberately planned out the exact order they would shut off parts of the spacecraft to maximize its scientific lifespan. Of the 10 identical sets of instruments on each Voyager, 7 had already been turned off. Now, it was time for the next one on that list.
That instrument on the chopping block was the Low-Energy Charged Particles Experiment, or LXCP for short. This isn't just some piece of metal, it is a scientific marvel that's been operating almost without a single interruption for nearly 49 years. Just imagine keeping a piece of electronics running continuously for half a century while it's being subjected to the absolute harshest conditions of deep space. It was an incredibly heavy decision for the JPL engineers. Turning it off was essentially saying goodbye to a reliable old friend that had been sending us secrets of the universe for decades.
And I mean, just look at the resume of this incredible instrument. The LECP was designed to measure low-energy charged particles, which includes ions, electrons, and cosmic rays originating from our solar system and the wider galaxy. Through all of this data, the LECP provided critical, completely groundbreaking information about the structure of the interstellar medium. It actively detected pressure fronts and mapped out regions of varying particle density in the uncharted space way beyond our heliosphere. This is the exact data that helps us understand the protective bubble surrounding our entire solar system. Losing the LECP on Voyager 1 basically means losing a unique and historic window into the cosmos.
So on April 17th, the fateful command was finally sent. But because of that staggering 15 billion mile distance, there was absolutely no instant gratification. It took roughly 23 agonizing hours for the shutdown sequence command to even reach the spacecraft. And then the shutdown process itself took another 3 hours and 15 minutes to complete. The engineering team just had to sit in nervous silence on Earth for over a day, waiting and hoping that the command was received, executed flawlessly, and that the spacecraft remained stable the whole time.
Now, what's really interesting about this is that the engineers didn't completely pull the plug. They actually left a tiny flicker of life. One specific part of the LECP, a small motor that spins the sensor in a circle so it can scan in all directions, was intentionally left on. Why? Well, because it uses an incredibly small amount of power, literally just 0.5 watts. By keeping this tiny motor running, the team is preserving the best possible chance of turning the entire instrument back on someday, just in case they miraculously find some extra power. It's this beautiful, tiny seed of hope left spinning out there in the infinite dark.
And that brings us to the future. Engineers are pretty confident that shutting down the LECP has bought Voyager 1 about a year of breathing room, and they aren't wasting a single second of that time. They're actively finalizing a massively ambitious new energy-saving strategy designed to extend the operations of both Voyagers. They call this bold strategy the Big Bang.
Let's break down how this lifeline actually works. Step 1 of the Big Bang plan involves swapping out a whole group of powered devices all at the exact same time, which is where it gets that dramatic nickname. Step 2 is replacing those active systems with lower power alternatives. And finally, Step 3 is the ultimate goal. By reducing the overall power draw through this massive swap, the team hopes to retain just enough electricity to keep the spacecraft warm enough to continue gathering science data from its remaining active instruments. But obviously, you don't just test a massive, unprecedented system swap on a deeply compromised spacecraft without a rehearsal. Luckily, humanity has 2 of these explorers. Voyager 2, for context, actually had its own LECP shut off back in March of 2025. Today, Voyager 2 has a little more power to spare and is slightly closer to Earth than Voyager 1, which makes it the much safer test subject. So engineers plan to test the Big Bang on Voyager 2 first, targeting May and June of 2026. If those tests go smoothly, the team will attempt the exact same fix on Voyager 1, but no sooner than July.
The dedication of these engineers is honestly just astounding. Kareem Badardine, the Voyager mission manager at JPL, summed it up perfectly. The team remains focused on keeping both Voyagers going for as long as possible, and it's so important to remember that Voyager 1 is not dead. It still has 2 remaining operating science instruments, one that listens to plasma waves and another that measures magnetic fields. They're still working great, sending back data from a region of space literally no other human-made craft has ever explored. The commitment to preserving humanity's farthest reach is just unwavering.
Which leaves us with this final, really tantalizing question. Will the LECP ever be switched back on? Well, if the Big Bang test on Voyager 2 is a success this summer, and if the subsequent massive system swap on Voyager 1 goes perfectly in July, there is a real chance that tiny spinning motor won't be spinning alone for long. The Voyager team might just find the power margins to bring the LECP back to life. Until then, we wait, we watch, and we marvel at the ingenuity keeping a 49-year-old machine alive, 15 billion miles from home. Thank you so much for joining me on this explainer. What do you think the odds are for a successful July rescue? Keep pondering that, and I'll catch you on the next one.